Since its release to the community in November 2025, application vendors have been scrambling to provide headless interfaces to their products using a new standard called Model Context Protocol. MCP allows applications like Microsoft Copilot and Claude to provide a single interface to the functionality and data available in your existing applications. Copilot and Claude provide low-cost, fixed-price access to the most powerful AI models as soon as they are released, albeit with restrictions on usage. However, as we are about to see, the lowest cost and fastest models can be used to increase productivity and accuracy in the applications we use every day. Acting as an orchestration layer, the agentic capabilities provided by desktop AI apps call on tools provided by mainstream vendors. Tools do jobs like find emails, get the details of a workspace, and run a workflow. In this demo, we are going to use the contents of an email and the location of a workspace to onboard a new client. The information we need is buried in the details of this client email. We are on Claude's standard team plan, which costs around £20 per month. Before we start, we can see we have previously used 3% of our token limit for this 5-hour period. For this demonstration, we will use Claude's cheapest, fastest model, Haiku. We will first ask the AI to find the email and give it a hint by explicitly telling the LLM the email is in Outlook. Claude tells you what it is doing, and we can see it starts by using the Outlook email search tool. It extracts the basic email information and suggests a next step, which we will ignore and instead give it a second task of finding the document's workspace. You can see Claude shows the iManage icon when it is using iManage tools, and because I have given it incorrect information, it will try several strategies to find me the closest match. It has come back with a couple of suggestions, demonstrating its ability to work through a problem. Now we have the email and workspace context. We can run the workflow to extract the details from the email. Previously, the LLM only read the email metadata, and at this point, it knows it must read the full body contents of the email. Using MCP, the AI finds a Cicero tool which identifies the appropriate workflow for the task. The AI's agentic workflow is then directed to use a second tool that defines the information that needs to be extracted from the email. The final tool in this agentic workflow is a Cicero-governed workflow, which runs on the Cicero server and creates a record with a full audit history and completed a set of predefined tasks, which, in this custom workflow, includes the creation of a branded email sent via SMTP with a link to the details of the new client. The information has been extracted from both the Outlook email and iManage workspace and added as structured data into the correct fields in Cicero. If we take a look at the costs of the entire process, this task has taken us from 3 to 5% token usage for this session, equivalent to much less than a penny of AI usage to complete a task that might have taken an hour or more if completed manually. As well as being very cost-efficient, a headless approach integrates existing applications without the need for vendor involvement and uses live data with full access level control, removing any need for data duplication. Cicero's governed workflows can access in-house knowledge, produce complex documents, and even allow access to non-MCP compliant systems. For more information, contact info@cicero.com.